Alright, so let's go through checkpoint 13. Okay, so this checkpoint 13, steel ball of mass M is attached to one end of the light rigid rod, right? So the other end is attached to a frictionless swivel joint. So when given a shaft, right, the rod rotates in a vertical circle of R. So of course the rod remains in tension throughout the motion. What is the variation in magnitude of the tension in the rod during one revolution of the stone? Okay, so for this, we need to apply the concept of PCOE and of course your centripetal force in order to solve this. Okay, so I think for point number one, we assume that the thing is moving, also with some speed. Of course, I call it the speed VT because it's called V top, right? Velocity top. Okay, then at the bottom is also there's some velocity. So it's called it we call it V bottom. So of course for the V bottom, definitely it will be larger. This is due to the fact that at point one, right, you are at the top. So when you go to the point number two, since the loss of GP, right, will convert to more KE, so means that the speed will be greater. Okay, so first we always start off with the PCOE. So K1 plus GP1 is equal to K2 plus GP2. So of course GP1 is mg2r. K1, okay, let's call it half m VT square. Okay, then at point number two, right, K2, which is half mvb square plus GP2. Okay, there's no GP, so means I set it to 0. So this part must be equal to this. Okay, so the next step actually we need to do is to look at the centripetal force. So let's take a look at the top first. Okay, at the top, so T1 plus mg, so this will actually give me the centripetal force of mvt square over r. So I want to make it in terms of the half mv square. So you can see it's very similar, right? So I just move the r to the left hand side. So T1 plus, T1r plus mgr. So this will actually give you mvt square. So you just need to times half throughout the equation. So half T1r plus half mgr equal to half mvt square. So meaning that at the top, right, the kinetic energy in terms of T1 r mg, right, is this. So you can see you just sub inside here. So this will give you half T1 r plus half mgr. So this is the kinetic energy at the top, but don't forget you must add on the this one mg2r, right? So it's as well as saying 2mgr, 2mgr. So this will be the total energy at the top. Okay, let's take a look at the total energy at the bottom. So okay, let's deal with the kinetic energy first. So at kinetic energy, right, second point, just say that not the kinetic energy, the centripetal force, so it's equal to T2, because they will have different tension at the top and at the bottom. So at the bottom, the tension T2, right, will be definitely larger than T1. So T2 minus mg, so is equal to mv bottom square, v bottom square over r. So same thing, you move the r to the left hand side. So T2r minus mgr. So it's equal to mv square b over r. So you just need to times half throughout. So half T2r minus half mgr. So this will give you half mvb square. So in terms of the in terms of T2r mg, right, so the kinetic energy of the steel ball, right, at the bottom will be this thing. I just put inside here. So let's submit. So okay, so at point number 2, right, the total energy will be just the kinetic energy, right? So the kinetic energy will be half T2r, half T2r minus half mgr. So for this is quite a lot of algebra, also sad to say. Okay, then point number 1, the total energy is this, right? So this part from half T1r plus half mgr, this one is your kinetic energy. Then this part is known to be your GPE. Okay, then since we know that PCOE applies, right, so we just put them together. So half T1r plus half mgr. Okay, so for this, right, just add them together. So it's 2.5 mgr. So this will equal to the second energy, right? So this one is the total energy at the bottom of the loop. So half T2R minus half mgr. Okay, so after setting this so-called PCOE equation, right? Okay, so they actually ask us one thing, right? What is the variation in magnitude of the tension in the rod during one revolution of a stone? Meaning that we want to know what is the difference between the tension T2 and T1. Because always remember, T2 the tension is maximum. Then T1 the tension is actually minimum. So I believe what they are asking is the maximum tension minus away the minimum tension. Okay, so let's use this equation to find, right? Okay, so what I want to do now is actually to move this over, and of course I want to move this over to right hand side. Okay, so 2.5 mgr plus 0.5 mgr, so this will actually give you 3 mgr. Then the next thing is half. Okay, so this is half T2R minus half T1R. So of course, okay, first thing I want to get rid is the R, because you can see that R is throughout the equation. So R. So after that, you times 2 throughout the equation. So 6 mg equal to half times 2 is just 1. No? So T2 minus T1. Yeah, so you can see T2 minus T1 is the tension 2 minus away tension 1, right? It's as good as saying the maximum tension minus away the minimum tension. So this will actually give you 6 mg. So the answer actually for this, is actually D. Okay, so that is my mistake.